Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you another example of the application of integration in physics. So this is an example related to the force required in order to maintain a spring that is stretched x units beyond its natural length. So x here represents the unit, so x units beyond the natural length. So according to Hooke's law, the force required is proportional to the units that is stretched beyond the natural length. So this is represented by x. And it is a simple function actually. So we have this function that depends on x, and this function is equal to kx. So k here is the positive constant, and this is called the spring constant. And this function here is applicable provided that x is not too large. So what is x? X is the unit that is stretched beyond the natural length. Okay, right. In order to show you the idea of this representation here, this idea here, we will be looking at a simple example. So this is example 6.4, where you have here, what you have here is the force of 40 Newton is required to hold a spring that has been stretched from its natural length of 10 centimeters. So this is the natural length of 10 centimeter to a length of 15 centimeter. So in this case, x here is 15 centimeter minus 10 centimeter, because we are looking at the units that is stretched beyond the natural length. So x here is 5 centimeter. Now notice that the force is given in Newton, so we are talking about SI metric system here. And since we have learned that force is in Newton, therefore when you talk about the unit has to be in meter. Okay, so x 5 cent, I'm sorry. So here x is equal to 5 centimeter, but we have to work with a different unit, which is meter. So we're going to convert 5 centimeter into meters, and that will be equal to 0.05 meter. Okay, so next, how much work is done in stretching the spring from 15 centimeter to 18 centimeter? Now, in order to find how much work is done, we need to be able to come up with the function here first. Okay, so this is the function according to Hooke's law. Now, we are going to use the information given in the first sentence in order to find what is k. So if I consider the function, so the function given here is, according to Hooke's law, is fx is equal to kx. So if I substitute x into this, if I substitute 0.05 meter into x, so I will get 0.05. I should be able to get the answer must be 40 Newton, because this is a function that represents the force. So when I substitute 0.05 meter into this function, the result must be 40 Newton according to this statement here. So the result is 40 Newton. So we know that f 0.05 is equal to kx. So I can say that 0.05. So I'm going to substitute that into that. So k 0.05 must be equal to 40. Therefore, I can find what is the value of k. The value of k is 40 over 0.05, and this is equal to 800. So this is the positive constant, or the spring constant. So once you have managed to get the constant, therefore we can continue with finding the work done. So therefore Fx is equal to 800x. Okay, how much work is done in stretching the spring from 15 centimeter to 18 centimeter? So recall that x here represents the units stretched beyond the natural length. Therefore, when I want to integrate this function, so this is 800x dx, I need to find what is the lower limit and the upper limit. So the lower limit is not 15 centimeter, because I need to know what is the units stretch beyond the natural length. So I need to consider 15 minus 10 centimeter. So that is a value of x. So 15 minus 10 is 5 centimeter. So 15 minus 10 is 5 centimeter. And I need to convert that to meter, because the unit has to be in meter due to, well, what you have seen here. I'm sorry, due to the fact that we want it to match the SI metric system. So when we talk about force in newtons, therefore when you talk about force in newtons, therefore the distance here must be expressed in meters, so that we can represent the work done in terms of joule. Okay, right, so back to this. This is the lower limit. Okay, 15 centimeter minus 10 centimeter is equal to 5 centimeter, and this is equal to 0.05 meters. So the lower limit is 0.05. The upper limit is the spring is stretched to 18 centimeters. So 18 minus 10. So 18 minus 10 is equal to 8 centimeter, and this is equal to 0.08 meters. So this will be the upper limit to be considered. Alright, next we're going to integrate this function. So the result will be 800 x squared over 2. It will be evaluated at 0.08 and 0.05. So this one will become 400. X squared will be 0.08 squared minus 0.05 squared, and of course you can punch in these numbers into the calculator, and you will get that the answer is going to be 1.56, where the unit is going to be joule. Okay, this is the unit. Since we are talking in terms of SI metric system, this is the force in Newton, the distance is in meters, and therefore the unit is going to be in joule. Okay, thank you very much for watching, and I'll see you in the next video.